Hello friends, welcome to video lecture on engineering mechanics. In the today's session, we'll learn about the numericals on centroid topic. So in this way, problem is given. You have to find out the centroid of the shaded area. Okay. So as per our step related with the centroid topic, we need to just divide this composite plane area into regular shapes. Okay, so if you just look towards this one plane area given here, so if you just see here, this portion, then next portion is here. Okay, now first of all divide this entire area into regular shapes. For that, if you focus on this portion, this portion is nothing but your quarter circle. I'll draw the diagram for that quarter circle. Okay, by considering this is nothing but the origin. Okay, this indicates the y-axis, this indicates the x-axis. Okay, so already whatever the names given here, a, b, everything you have to just take as it is and redraw the diagram for the particular part. Okay, so I'll say this is nothing but the part number 1. Okay, this one part number 1, this indicates the part number 2. Okay, so this indicates the part number. Here if I just see, okay, first of all draw the diagram for this one. Okay, I'll draw the diagram for the quarter circle by considering this as origin. Y-axis is here, x-axis is here. Okay, now as per our details given in that table regarding the regular shapes, what's about the x bar and y bar value, means what's about the centroid for the regular shapes, already I discussed about that. So in this case, just locate this g1. So at a distance of x1, this is nothing but the x coordinate of this g1. At the same time, this indicates the y coordinate of that g1 point. Okay, so in this case, once the diagram is drawn by you, then next one, by considering this is nothing but the quarter circle, just get the its area. So what's about the area? Area for this one is nothing but the a1, pi r square by 4. Okay, why 4? Because the quarter circle with us. Okay, so what's about the radius given? 3 given. Substitute the value of radius here. Pi r square means here pi 3 square by 4. If you do the calculation, you can get the 7.07 centimeter square. Now focus here. What's about the formula given in case of quarter circle regarding this x1 y1 or x bar y bar? 4r divided by 3 pi. This formula already we know it. Okay, so if you just see distance, this distance and this one is the same. Okay, so here 4r means 4 multiplied by radius of this quarter circle with us 3 divided by 3 pi. To the calculation, you can get the same value for this x1 as well as y1. So you can get 1.27 centimeter. Now focus on this one left side portion. Okay, now if you just see, this is nothing but the square with us, and if you just subtract this portion, once again the quarter circle, from this square, the remaining area we can get in this way. Okay, so consider this one, this square portion. Okay, so what's about this one? Here already the name is given DCAO. Now this area available with us towards the left side of that origin point. Okay, so what's about the centroid of the square? So here we can get the coordinates for the same x2 y2. Okay, x2 horizontal distance, y2 indicate the vertical distance. You can just write in this way, x2 y2 here comma. Now whatever the area of this one, area, so here is the area with us. A2 is nothing but 3 centimeter. Radius for this one given means this length must be, length for this side must be 3 centimeter and length for this side must be again 3 centimeter. What's about its area? Area is nothing but here 3 multiplied by 3. You can get the 9 centimeter square. So what's about the next one? Now we are moving towards the left side of that origin. So what's about the half of this one? So in case of the where we know the centroid lies at a distance of half of the base length. So what's about the base length with us? 3 centimeter, because this actually this length radius will remains here the same. Okay, this length and what is the radius of this one? Okay, the same one. So here in this case 3 by 2 will come, but as we are moving towards the left side of that x-axis, okay, origin, so this must be negative. So 1 point minus 1.5 centimeter. So what's about the y2? Y2 is nothing but this side. Again, this side, length for this side with us 3 centimeter. So half of 3 centimeter is nothing but the 1.5 centimeter. Now, next portion we are considered as quarter circle. If you look towards this one, this indicates the quarter circle. Okay, this is the quarter circle. Again, I'm just repeating here. So whatever this circle, this one quarter circle we have drawn here, that is not an actual part of our diagram, but to get the center of entire portion, just dividing the this portion composite area into regular shapes. So what's about this one quarter circle with us? So draw the diagram for the quarter circle by considering the same geometry. Just pick up this portion only, this portion, okay, and just draw the diagram here. So here is the origin. Don't change the position of the origin. Okay, this indicates the y-axis, this indicates the x-axis. Okay, so this indicates the G3. D point is here. Now what's about this one? Always remember that nearer with this center, we can get this height as 4r divided by 3 pi, and this one is nothing but the again 4r divided by 3 pi. So here if you just see the previous quarter circle, this one quarter circle with us, this distance is nothing but the 4r divided by 3 pi. This distance is nothing but 4r divided by 3 pi. So exact reverse case with this one. So this distance, this distance with us 4r divided by 3 pi. What's about the remaining distance? For that we know the base length for this one 3 centimeter with us. Okay, now before that focus on this, whatever the area in front of you. Okay, this area should be negative area. Why? Because this is not actual part of this one, actual part of the diagram. To convert this one into regular shape, you just consider this one is nothing but the extra portion. Okay, so that's why you have to subtract this this area from the entire area. Okay, at this stage just do the negative sign for this one, because this area should be subtracted from the total composite area. Okay, so here minus a3 indicate the area of this one, minus 4r, sorry, pi r square divided by 4. So what's about the pi? What's about this one? R with us 3 centimeter. Okay, substitute here 3 square by 4, do the calculation, minus 7.07 centimeter. Okay, that will come here. Now this point is very important one. So what's about the x3? X3 is nothing but this distance. X3 is nothing but this distance, and as per formula this distance is nothing but the 4r divided by 3 pi. This distance as per formula. Okay, similarly as per formula this distance with us 4r divided by 3 pi. Okay, so what's about this one? 4r divided by 3 pi. This distance is required. So what's about the base length for this one? 3 centimeter with us, means to get this distance, entire distance with us 3 centimeter, you have to just subtract this term from the 3 centimeter. So here that term is written. Okay, just we are moving towards the negative side of the origin, that's why the minus sign is given here. So total distance with us 3 centimeter minus 4r divided by 3 pi. Okay, do the calculation, check the answer for x3. After doing calculation, you get the value for x3 as minus 1.73 centimeter. Now what's about the y3? Similar case with the y3. This distance with us, this one with us 3 centimeter. 3 centimeter. Out of this 3 centimeter, this distance with us 4r divided by 3 pi. What's about the y3? So y3 is here. 3 minus 4r divided by 3 pi. Okay, so do the calculations for this one. You can get the y3 equals to 1.73 centimeter. Okay, So centroid of the given shaded area is given as, for that if you just say the formula with us, x bar equals to, so what's about the formula? We know the formula a1 x1 plus a2 x2 plus a3 x3 plus summation of all the areas. Okay, this formula we know it. Okay, so what's about the a1 x1? A1 x1 means here the area for the first part with us 7.07. Okay, multiply by, what's about this x1 1.27. Okay, plus next one with us 9 multiply by minus 1.5. What's about the 9 indicate the area for the second part. 9 multiply by minus 1.5 plus next one. What's about this one? Already this area minus area with us, so minus 7.07 multiply by, what's about this one? This indicate the x3 term. So what's about the x3? Minus 1.73 divided by summation of all the areas. So what's about this area? 7.07. Next to this one 9 centimeter square. Next to this one minus 7.07 centimeter square. Okay, so substitute here all the values, do the calculation, you can get the value for x bar. So x bar we can get 0.8566 centimeter. Okay, so at the same time we know the formula for calculation of y bar. So y bar is nothing but here a1 y1 plus here a1 y1 plus a2 y2 plus a3 y3. We know this a1 once again here 7.07 multiply by y coordinate of the same, so y coordinate is here 1.27, so multiply by this term by 1.27 plus next one 9. So 9 centimeter. Okay, for the a2 9 multiply by 1.5. 1.5 indicate, so here is the 1.5, y2 value with us 1.5. okay, so next one with us a3 a3 with us minus 7.07 multiply by y3 with us 1.73. okay, so divided by, what's about the next one? Summation of all the areas. So here 7.07 plus 9 minus 7.07. okay, in this way substitute all the values, do the calculation, we can get the value for y bar. So y bar after doing calculation we can get 1.139 centimeter. So at last write your answer like this one: coordinates of centroid with respect to origin O are G, in the bracket this indicate the x coordinate, this indicate the y coordinate. Okay, that is 0.8566 comma 1.139 centimeter. I hope this problem clear to you. Okay, so once actually this one, whatever the composite area is given, you should divide this area into regular shapes like this one. At last it is not necessary to draw once again this diagram. Okay, now we'll move towards the next problem. Now continue with the next problem. Find the centroid of the shaded area as shown in figure. Okay, in this way the shaded area in front of you, you have to find out the centroid of the same. Now if you look towards this diagram, here in this case this object or this whatever the plane area is in front of you, that is symmetrical about the y-axis, because this distance, this one, okay, if you just see, and whatever the this portion available with us, exactly this portion is symmetrical about the y-axis. We can, if you just fold this one, can get the mirror image of the same. Okay, now in this case what do we take the advantage of the same? Here if you just say the object is symmetrical about the y-axis, means automatically the value for the x bar is 0. It is not necessary to do calculations for the same. Okay, so half task is over here. So here just mention the given figure is symmetric about the y-axis, therefore x bar equals to 0. Okay, now we'll divide this composite area into small regular parts. Okay, for that, if I just draw here one dotted line in this way, draw here dotted line in this way. Okay, now you just see here you can get the different parts of the same composite area. You just see one triangle is here, then you can get here one rectangle. Okay, here you can get the already this one semicircle with us. Then here we can get the again one uh, triangle. Okay, right angle triangle. Here we can get the right angle triangle. Here we can get the right angle triangle. Here we can get the rectangle. Here we can get the semicircle. Okay. Now at the same time, either you draw the diagram separate if the geometry is complicated. Okay, or you can just mark on the same diagram, no problem. So here this indicate the part number 1, this indicate the part number 2, this indicate the part number 3, this indicate the part number 4. Now if you look towards the geometry in front of you, so this one, this one, this one, these are nothing but the positive areas. And what's about this one? This area is nothing but the negative area. Okay, so if you subtract this area from the entire this one trapezoid, we can, what we get here we can get the centroid for the this one shaded portion only. For that, consider this one is nothing but the triangle. Okay, so triangle is here, then rectangle next to this one, then again triangle is here, then semicircle with us. Now consider the triangle ABH. What's about the area for the same? Area for this one, 1/2 base multiplied by height. What's about the base? 10 centimeter with us. What's about the height? 30 centimeter with us. Do the calculation and get the value for the area. 150 centimeter square in this way. So what's about the y1? Y1 is nothing but, we focus on this particular portion. So this indicate the y-axis, this indicate the x-axis. Now we are moving towards the this one. You just focus on this particular point. So what's about this one? So this distance is nothing but, here in this case this distance indicate the y1. So this distance indicate the y1. Okay, from this point up to here, already written here, y1 equals to y3. If we just consider this portion, you can get the same thing. Or you can draw the separate diagram, no problem. In this way, just draw the diagram. In this way, draw the diagram for the next part. Draw the diagram for the next part. Okay. Now see the position of axis. Okay, and take the reference of that position of the this one reference axis and get the information regarding the its coordinates. So here in this case, so y1 is nothing but this one. So what's about the y1? As per formula, we know. So here, what's about the height? 30 centimeter with us. Height by 3 is nothing but the formula in case of the right angle triangle. So what's about the height? 30 centimeter with us. Divided by 3, you can get the 10 centimeter. Okay. So just moving towards the positive side of the y-axis. That's why the plus sign is given here. Now consider the rectangle. So here is the rectangle HBCE. What's about the area for the rectangle? Area is the but here base length multiplied by height. Base length with us 20 centimeter, height with us 30 centimeter. So 20 multiplied by 30 equals to 600 centimeter square. What's about the y2? So y2 is here. Y2, whatever the total height of this one by 2, 30 centimeter by 2. What do we get here? 15 centimeter. Now move towards the next part, that is right angle triangle. Okay, so in case of that right angle triangle, what's about the A3? A3 is nothing but the area of this portion. What's about the area? So area of the right angle triangle, 1/2 base multiplied by height. So base with us 10 centimeter, height with us 30 centimeter. So 150 centimeter square we can get after putting the values of base and height. So what's about the y3? So y3 we can get the here height divided by 3. Y3 is nothing but the coordinates of this point, vertical coordinate of this point. So what's about this one? 30 by 3. In this you can get it. After doing calculation you can get the 10 centimeter. Now consider the next one, semicircle HFE. So here is the semicircle we have considered HFE. Either you draw this diagram separate and show the coordinates on the same, or can make the changes on the same diagram, no problem. But you need to identify where is that x bar, y bar for the particular part lies. So here, what's about the radius of this one? Radius of this circle with us. But here the 20 centimeter diameter with us. So what's about the radius of this one? We can get the 10 centimeter. So what's about the area for the same? Now, if you focus on this one, this is nothing but the negative area. You have to subtract this area from the total area so that you can get the centroid of entire area. Okay. For that, you need to subtract this area. So what's about the this one minus? That's why the minus a4 is written here. So minus a4 equals to minus this one pi r square by 2. Because this is the semicircle. Pi radius with us 10. Okay, 10 square divided by 2. After doing calculation, you can get the area for the same portion as minus 157.08 centimeter square. So what's about the y4? Y4 is nothing but this is the distance. 4r divided by 3 pi. 4r divided by 3 pi. What's about this one? 4r divided by 3 pi. R with us 10 centimeter. Substitute here and do the calculation. We can get the y4. Y4 equals to 4.24 centimeter. Now move towards the next one. Centroid of the given shaded area is given as the formula with us. Y bar equals to a1 y1. Why we are doing the only calculations for the y bar or for the one coordinate only? Because the other coordinate already here we get the value for this one 0. How? Because this object is symmetrical about the y-axis. Means automatically we can get the value for that x bar equals to 0. That's why here only with respect to y bar this formula is written. So we know this formula. Y bar equals to a1 y1 plus a2 y2 plus a3 y3 plus here a4 y4 divided by a1 plus a2 plus a3 plus a4. So why this one minus sign is given for this a4? Because this is the negative area. Now substitute the value for a1 y1. What's about the a1 with us? A1. So a1 with us 150 centimeter square. Substitute here. What's about the y1? 10 centimeter with us. Substitute here. What's about the a2? 600 multiply by y2 with us 15 plus next one 150 with us multiply by 10 minus next one 157.08 multiply by this y4 with us 4.24. Okay, so divide by what's about this term 150. Once again we know this area a1 plus a2 plus a3 minus this one a4. Why minus? Because this is the negative area. Okay, so substitute everything and do the calculation. We can get the y bar equals to 15.26 centimeter. So the coordinates of the centroid with respect to origin O are G 0 15.26 centimeter. So let us discuss about the next problem. So here's that problem. Three plates ABC, BCDE and DEF are welded together as shown in figure. Okay, so circle of 1.5 meter diameter is cut from the composite plate. Determine the centroid of the remaining area. So this portion is cut from this entire composite area. Our aim is to find out the centroid for this area by subtracting this circular portion from this composite area. For that, first of all, just draw the separate diagram for this portion, this portion, this portion. Okay, so whatever the areas in front of you, try to just divide that areas into regular shapes. Okay, so if you just see here one triangle, okay, one triangle in front of you, then next one is nothing but here if I consider the BCDE as another rectangular part. So what's about this one? This indicates the semicircle, vertical semicircle like this one. Then next one is nothing but here this area. This area portion we are considered as the fourth one. This area. So if possible, try to show this one by taking the reference of this one x and y, or if possible you can just try to show all these things on the single diagram, no problem. Okay, so this one we are considered as the first one, triangle. Then this one we are considered as the next portion, that is rectangle. Then we are considered this one as semicircle, and here is the next one, fourth part indicate the circle. Okay, now consider the triangle ABC. If I consider this triangle ABC, now our aim is to get its area, its coordinates along the x-axis, along the y-axis with respect to axis. So here is the y-axis and here is the x-axis. If I get this one x1 and y1 at the same time, if I get the area of the same, my task is over. So what's about the area of this one? We know the formula for the this one right angle triangle. Okay, a1 is nothing but the half multiplied by base length. Base length was the same with us, 3 centimeter. What's about the height of this one? So height is nothing but here, if we just see here, if I move this circular part, this one, so radius for this portion is given 2 centimeter, and here we can get the 2 centimeter. Means height we can get here 4 centimeter. Okay, so in this we can get the height for this portion as 4 centimeter. Okay, so here the area we can get in this way, 1/2 base multiplied by height with us 4. After doing calculation we can get the 6 meter square. Okay, so what's about the x1? So as per the formulas given, this portion is nothing but the 4r divided by 3 pi. Okay, so this indicate the x1. So here the triangle, if you just say the face side of this triangle is nothing but here towards the exact opposite side of this one, origin. That's why. So what's about this one? This portion indicate the 4r divided by 3 pi. This length 4r, sorry, this indicate the whatever the base length with us. Base length for this one 3 meter with us. So 3 by 3. Okay, 3 by 3. In this way can get it. Okay. So what's about the total area? Sorry, total length for this one? If this one is nothing but the 1/3 of this one, so this portion indicate the 1/3, means what's about the remaining one? X1 is nothing but 2/3 multiplied by 3. Okay, so this one must be 2/3, this one must be 1/3. Okay, so 2/3 multiplied by 3. So what's about this calculation? We can get the 2 meter. Now what's about the y1? So y1 distance with us, height by 3. So what's about the height? 4 centimeter, 4 meter with us. What's about the this one? Height 4 centimeter by 3. So 4 by 3 is nothing but the 1.33 meter. Now move towards the next one. Here is the this one rectangle with us. So height for this rectangle with us 4 meter. At the same time, what's about the base length for this one? 3 meter. What's about the area? 3 multiplied by 4 is nothing but the 12 meter square. Okay. So what's about the x2? X2 is nothing but the half of this one. What's about the x2? This distance indicate the this one. So this distance is nothing but the x2 from this point up to here. This distance indicate the x2. Okay. So what's about this distance? This distance as per formula base by 2. So what's about the base length with us? 3 meter. 3 meter by 2 plus this distance. This distance with us 3. Now see how this formula is written here. In case of the rectangle, x2 is nothing but the 3. So what's about this one? 3 plus 1.5. So what's about this 1.5 indicate? Half of this 3 meter. Half of this 3 meter is nothing but here 3 plus 1.5. What do you get here? 4.5 meter. What's about the y2? Y2 is nothing but this vertical distance. Vertical distance. Here is the y-axis. Here is the x-axis. Keep your eyes on this axis so that we can get the value for this one, x bar and y bar easily. So what's about this this one? This height is nothing but total height with us 4 by 2. 4 by 2 means here what do we get? 2 meter. Okay, here actual formula with us 4 by 2. So From this one, you can get the 2 meter. Okay. So move towards the next part. So here is the semicircle given. Now see the axis position is here. X-axis is here. Y-axis is here. So with respect to this one, I want this distance. Here is the just focus on this semicircle. The semicircle we have drawn here, like this one. My aim is to get the distance of this centroid along the x direction and along the y direction. So what's about this horizontal direction? Up to here, up to center of this semicircle, we know this one, this horizontal distance. What's about this one? 3 meter plus 3 meter. Again, I want this distance, means this distance of this one. So what's about this distance? 4r divided by 3 pi. See what's actually written here. 3 distance is here, then 3 distance is here. 4r divided by 3 pi. What's about the r? R is nothing but the radius of this semicircle. Radius with us 2 meter divided by 3 pi. Do the calculation. You can get as 6.848 meter. Okay. Now what's about the y2? Y2 we can get easily. So what's about this distance? Vertical distance. Total radius is given to meter, means diameter of this one 4 meter. So half of this one, again 2 meter will remain. Okay. So what's about the next one? Now consider the circle with center O. So here is the circle. Now see the position of this circle with respect to this y-axis and x-axis. What's about the position of the center of this circle from the this one x-axis? So exact the half of this one, half of the diameter of which one? Semicircle. So what's about this one? Total with us 4, means half of this one we can get the 2. Look to us here. Here the 2 meter with us. And what's about the area for this? Area of the circle? Pi r square. As this is the negative area, that's why the minus sign is given here. Okay. So here in this case, the radius of this one. So diameter for this one given how much? 1.5 meter. Diameter. This phi sign indicates the diameter. So phi 1.5 meter. So half of this one you can get the 0.75. Okay. So 0.75 meter with us here. Minus. Why the minus sign is given? Because this is the negative area. You have to subtract this area from entire area so that you can get the centroid for the effective area, okay, or shaded portion. So in this case, we know the radius for this one, pi r square, means radius of this portion is with us 0.75. Do the calculation, you can get the minus 1.767 meter square. What's about the x4? X4 is nothing but here. X4 means here the centroid. Location of this centroid here, sorry, x bar. Okay. So what's about this one? This indicates the x4. Now see the direct location of this point with respect to this y-axis. 3 plus 3, 6. So you say you can get the x4 as 6 meter. Now write the formula here for the x bar as well as for the y bar. We know the formula for x bar. X bar is nothing but a1 x1 plus a2 x2 plus a3 x3. Why the minus sign given? Because this is the negative area, that's why the minus sign is given. Minus a4 x4 divided by summation of all the areas, means here a1 plus a2 plus a3 plus a4. As this one is the negative area, that's why the minus sign is given. Now substitute all the values here, do the calculation and get the value for the x bar. Similar case with the y bar. So in case of y bar, we know the formula a1 y1 plus a2 y2 plus a3 y3 plus a4 y4. As the area is negative, that's why the minus sign is given. Divided by a1 plus a2 plus a3 plus a4. So minus sign is given here because the negative area. Okay, do the calculation. After substituting all the values, we can get the y bar equals to 1.82 meter. Okay. Now the coordinates of the centroid with respect to origin A, R, G, 4 point. So G indicate the centroid. Okay. What's about the x bar? So x bar with us here 4.37 meter. 4.37, 1.82 meter. Now, let us start with the next problem. So here is that problem. Determine the centroid of the shaded portion as shown in figure. So in this way problem is given. Okay. So if you look towards this one, the shaded portion with us, this is the shaded portion. This way shaded portion is given. Means one thing clear here, you have to subtract this area from this entire portion. Okay. Now as per our discussion, you need to divide this composite area into regular part. Okay. Now think over it. So I can just divide this plane area or composite area into regular shapes. For that, if I join this one, join this portion with this one. Okay. Now same actually shown here. So what we get here? So in this way you can get this is nothing but the semicircle. Here you can get the triangle, and if you look towards this one, you can get here as a sector. Okay. Now if you focus on this one, I'll just say this sector is nothing but the number one. Number one is given for this sector. So see the dimensions given for this sector: 100 units radius for this one, or 100 mm radius is given for this portion. So 100 mm radius you can get it here. So what's about this angle? So first of all, just from this geometry, try to get the required things related with this sector. Okay. So here is the sector number one should be given for this sector. One more interesting thing about this one, so x-axis is given here, y-axis is given here. Means this object is symmetrical. This actually geometry is symmetrical about the y-axis. So the exact mirror image you can get if I just fold this geometry. You can get exact mirror image of this one. So this is the symmetrical about the y-axis. Means here we can get that centroid on the y-axis. Here in this case, x bar becomes 0. Okay, the given figure is symmetrical about the y-axis, therefore x bar is 0. Okay, I think this point clear to you. Next one, divide this composite area into small regular shapes. Okay, in regular shapes. Okay, here you can get the sector with the number one for this one. Next one with us here, the triangle with us. Next one with us, semicircle. Okay, you should subtract this semicircle. If I add this portion with this one, if I add this sector with this one, by subtracting this portion, what do we get? We can get the exact area of this shaded portion. Okay, so for that, first of all, concentrate on this sector. So in this case, if we look towards a triangle COE, from this triangle, if I use the cos as trigonometric function here, cos of theta is nothing but the adjacent side with us OE. OE divided by, so what's about this one OC, OE divided by OC. In this you can get the relation for that cos. So cos of theta is nothing but OE with us. What's about this OE? OE, this is the OE, 50 with us. What's about this one? Again, this indicates the radius of the circle. So this one already with us 100. So in this way, we can get the value for the theta. So what's about the theta? 50 by 100. Cos of theta equals to 50 by 100. Take the cos inverse of this one. So what we get? Theta equals to 60 degree. So this angle COE is nothing but 60 degree. If this angle with a 60 degree, what's about the remaining one? Automatically we can get the 30 degree. So this angle is 30 degree. This angle is 30 degree. So what's about this portion? This angle 180 degree with us. This angle must be 180 degree. So out of this 180 degree, half of this one 90 degree plus 30 degree means here we can get the 120 degree in this way. So once actually this information with us, get the information regarding the area of the same. So we know the area of the sector. What's about the area of the sector? For that we know the formula. So what's about this? R square into alpha. So in this way formula with us for the area of that sector. For that, if just see the names given here for the part number 1, E, A, F, B, D, then O. In this way, part number 1 with us. Okay. What's about the area for the same? So area of the sector is nothing but the r square into alpha. So in this case, alpha with us 120 degree. Now you have to convert that 120 degree into radian at this stage. So multiply by this degree term by radian. So to convert that degree into radian, you should multiply to this degree by pi by 180. So do the calculation. We can get area for the sector as 20,944 mm square. So what's about the next one? Y1. So Y1 is nothing but in this case, this is this distance. So already the formula is given, ready-made formula is given 2r sin of alpha or 2/3 of r sin of alpha divided by alpha. So what's about this alpha star indicate? We should consider the value of alpha here in this case in radian. Okay. So here we know the 2r with r means radius of this one. Radius with us 100 multiplied by alpha sin of alpha. Now just take this one alpha as it is in this case. Okay, sin of alpha with us 120 degree divided by 3 multiplied by this r with us r 120. You should convert that by multiplying pi by 180. So after doing calculation, we can get the value for this y1 equals to 27.57 mm. Okay. Now consider the next one. So triangle with us here. Next part is triangle. So first of all, just from this geometry, get the base length for this one. But here we don't know the base length. Here the height of the triangle with us, then this one with us. So automatically we can get this length by using the Pythagoras theorem. Okay. So use the Pythagoras theorem here and get this one C length. Okay. So what's about that C? For that, if I consider the triangle COE or triangle COD, okay, from this triangle, no, sorry, this triangle you have to do calculation for the area and the coordinate. Okay. But if we consider this triangle, automatically we can get the length C by using the Pythagoras theorem. What's about this C? C is nothing but the square root of this side square minus square of this side. Okay. So we know this one 100, we know this one 50. Substitute here, do the calculation, check the value for the C as 86.6 mm. What's about the CD? After doing calculation, you can get this one E as 86.6. Okay. What's about the total length of this one? CD. So this plus this means 86.6 plus 86.86 means how much we can get? 173.2 mm. So what's about the area of this triangle? Area of this triangle is nothing but 1/2 base length with us 173.2 multiplied by height with us 50. Okay. So substitute here. After doing calculation, we can get the area for the same is nothing but the 4,330 mm square. And what's about the y2? For that, if you just see, here is the origin point and here is the x-axis, here is the y-axis. We are just moving below of that origin, means you can get the negative value for that y coordinate. So what's about this one? Now as per formula, this distance with us height by 3. This distance with us height by 3. So what's about the remaining distance? This one is 1/3 of height. This should be 2/3 of the height. So we are just moving below of this one, means you should give the minus sign for this. Minus 2/3 of 50. Why 50? Because the height of this one with us 50 mm. So the calculation, we can get the y2 equals to minus 33.33 mm. Now move towards the next one. That is the semicircle. So in case of semicircle, so here is the semicircle. Here is the position of that x-axis. Here is the y-axis. So in case of semicircle, what's about the area of the semicircle? So here we know the area for this semicircle. As this is the negative area, give the minus sign here. Pi r square by 2. So radius for this one with us 75. Radius for this semicircle with us 75. That's why we should just substitute the value of radius as 75. So here minus pi r square, 75 square divided by 2. After doing calculation, we can get the minus 8835.73 mm square. Okay. And what's about the y3? So y3 we can get. So here is that semicircle. What's about the y3? I need the distance of this one. This distance. Just focus on this one semicircle. I want this distance. Okay. Now we are moving towards the positive side of that x-axis. Here is that semicircle. Okay. So what's about this distance? 4r divided by 3 pi. This is the formula with us, 4r divided by 3 pi. As we are moving towards the positive side, means you should give the plus sign for this one. Here don't give the minus sign, because as per geometry we are just giving the, as per position of axis we are giving the plus or minus sign for that coordinate. But as this is the total entire area is the negative area, here the minus sign should be given. So what's about this one? 4r, r means here 75 with us, divided by 3 pi. So y3 after doing calculation we can get 31.83 mm. Now what's about the coordinates of the centroid of the given shaded area? So here in this case we know the related with the x coordinate is 0. Now what's about the y coordinate? For that write the formula a1 y1 plus a2 y2 plus y3 a3 y3 divided by summation of all the areas. So in this case what's about the a1 with us? A1 is nothing but the 20,954 multiplied by, what's about this y1 with us 27.57 plus next one, next this term with us 4,330. This indicate the a2, this term is here. Okay, substitute here. What's about the next one? y2. So y2 with us minus 33.33. Okay, now what's about this one? This is the negative area with us, multiply by this one, this distance. Okay, so as this area is negative, don't confuse in that negative area and its coordinate. Okay, coordinate should be given with respect to that which one, position of the axis, and area should be decided depends upon whether that area should be added or subtracted. Okay, this area should be subtracted from the entire one. Okay, get the our required area. Okay, so once we substitute all the values here, the a1 a2 a3 etc are substituted. Okay, so after doing calculation you can get the value for the y bar as 9.239 mm after doing calculations. Okay, now say the answer for this one, the coordinates of the centroid with respect to origin OR G0 9.239 mm. Thank you. Hope the concept of centroid with respect to various numericals on the same are clear to you.